Okay, so today I'm going to talk about the ECM model. This is a model used widely in the econometrics, but I think it's also widely used as a time series model because it's often used for the pair trading. The model, let's first begin with time series. Let's say we have a YT, we have a XT. And for time series, we usually do this. The change of YT is equal to delta 0 plus delta 1 times change of XT plus epsilon t, where this is the arrow term. But the ECM will claim what? ECM usually it assumes some long-term relationship between y and x. So ECM is something more than that because this is a time series for YT and XT. I mean, this box is a classic time series. That's it. I'm sorry. I think of course we have that's it because here is delta, so that's fine. It's a time series. But ECM assumes what? ECM assumes that actually this big Y is equal to some alpha plus beta of x expectation. Here we call it expectation or equilibrium. So this is a Y equilibrium and x equilibrium. We can consider as the non-term y or and non-term x, right? So in non-term, they are actually linear. So y and x, they must go in the same direction. And in this way, actually the time series we showed before does not make that many sense because it does not capture this non-term relationship. That's what we're going to do here. Again, we start with the time series. So step 1, we start with the time series. The time series usually looks like this, as the YT is equal to C plus delta 1 times XT plus delta 2 times XT minus 1 plus mu times YT minus 1 plus epsilon t. It's a time series. There's nothing introduced here. And then the next step, we can make a difference term. We can let YT minus 1 is equal to C times. Every term does not change. Here's minus 1. Then the next step is the key thing. So here, let's copy the first two terms. Times xt. Here, write as lambda times some YT minus 1 minus alpha minus beta times xt minus 1. Why this is true? Because we know for the non-term it should have this relationship. So we capture this relationship at this term. And of course we will add the arrow term at the end. So essentially we say these two terms, we can capture it as this. That is what we call the error correction model. And here this one, we usually call this relationship we call it co-integration. Okay, so let's continue. Here, let me show you several reasons. First thing is here it should be C prime, because we can combine each term, you can see the difference. So firstly, this term is I0, right? It's stationary. Let's say if y is I1 and x is I1, okay? So let's say if y is I1 and x is I1. So this is I0. And this term, I'm sorry, here I just jump one term. So here I can minus delta 1 times xt minus 1 plus delta 1 times xt minus 1. Right, then combine these two terms to be here. So it does not matter. So if this is I0, then this term is delta xt. So this term is I0. And for that term, because we have the equilibrium, so that term is also I0. Is because of the equilibrium. Then this whole equation will make sense. And here why we have a C prime, because here the lambda times alpha. So it's C prime plus lambda times alpha equal to C. And what do we have is delta 1 plus delta 2 divided by 1 minus mu is equal to beta. And lambda is equal to 1 minus mu. I think this three equation will hold, right? And then why this is useful? So the intuition behind this error correction model. So what's the intuition behind this name, error correction? It's because here we see this equilibrium, right? So suppose yt minus 1 is larger than alpha plus beta times x t minus 1, then yt minus 1 minus alpha minus beta times x t minus 1 will correct the error a little, which will make sense. Okay, that's the reason behind the name. Now, lastly, let's say the punchline. So ECM model, in my own language, is a combination of AR, which is autoregressive, and a linear regression. Since we see that delta y t is equal to, actually let's do a generalized term, is equal to delta 0 plus some sum I equal to 1 to p of delta p times delta xt minus I, and plus I equal to 1 to j delta mu j maybe times delta y t minus I, t minus j maybe, t minus j equal to 1 to k delta I, sorry. And then we add the long term is lambda times yt minus 1 minus alpha minus beta times xt minus 1 plus epsilon t. So this part is the autoregression part, is the AR part. And this part we can call it the co-integration, or we can just say it's a linear relation. So that's it. That's why we love the ECM model, because it's a combination of the short-term dynamics. So maybe you can call this the short-term dynamics, and plus it's long-term. This is a long-term thing.